Morning, girls. Substitution. Morning, Pedro. All right. Okay. So what I'm going to do is later this morning, I'm going to put out another assignment on just kind of a wrap up of chapter 8. So I'll get that for you this morning. And did you have any questions from the review in chapter 8 that you want to look at before I move on this morning, girls?
Yeah, I had a question on page 182, question 6, please.
Certainly. Okay, 182, question 6. Okay. Okay, so Jenny needs to rent a car for the day. The graph shows that the daily cost C of renting a vehicle from each of the two companies in terms of distance driven in kilometers. How can you use the graph to determine the basic cost of a rental car, excluding the distance charges and the distance charge per kilometer for each company? Okay, so what we should do is we should look at the graph and say to ourselves, okay, what's happening on the graph? So let's look at that right now. So I have the direct car and wheels to go car. All right. And so the initial cost for each based on the distance, okay, is given. So what's the initial cost before you drive it off the lot for wheels to go? What's your initial cost?
$40.
Right. And for direct car, what is it?
$60.
Okay, so initially, which is the better offer?
The $40.
The $40, the wheels to go. But the wheels to go goes up, its rate per kilometer obviously has to be greater than the direct car one because it ends up going much higher after a certain amount of distance, right? So to begin with, wheels to go is the better deal. So at what point do the two cars, the two rental agencies, at what point are they the same amount of money? How many kilometers do you have to drive for them to be the same amount of money?
80.
80, that's right. And then after 80, the better deal is the direct car deal, right?
Yeah.
Okay. So it says, how can you use this graph to determine the basic cost of a rental car, excluding distance charges and the distance charge per kilometer? So we just described that. We looked at the initial cost. We looked at the number of kilometers before that they're the same. And then after they're the same, which one costs more? So that's what we'll do. So it says, Jenny thinks she'll drive about 100 kilometers. Which company should she choose? So if she drives 100 kilometers, which one would be the better deal?
They're the same.
They're the same at 80 kilometers, correct?
Oh, okay.
And then after 80 kilometers, which one becomes a better deal?
Direct car.
The direct car, that's right. Okay, so that's just a very, very basic understanding of the actual graph itself. So just by discussing it in words, we can kind of figure out our options. Now, mathematically speaking, this is where we want to find our slope and our y-intercept in order to compare the lines, and then we can get a better idea as to what is the better option after the fact. So if I let My dependent variable, C, is being the cost, okay? Then I have my slope. Well, what is my slope? My slope is the rate per kilometer. Okay, that's what my slope is. So I'm trying to find out how much money it is for every kilometer that I go. All right, so I have M, and then they have distance here, right? They use that as distance, I think, on the bottom. Yeah. And then I have my y-intercept. So there's a lot of variables right now. Okay, so for the first company, wheels to go, the cost is MD, and it starts at $40. The one that's direct car, its cost is MD plus $60. So the moment you rent either one of these cars, the moment you rent wheels to go, it's $40. The moment you rent the direct car, it's $60. So now we want to find the rate for each of them. So what I want to do is I'm going to pick two coordinates here. So the first one's 0 and 40, and this one is 0 and 60. And then I'm going to pick the same coordinate. I don't have to, but I know I can read it on the graph very easily. So at 80 kilometers, it's $100 for each of them. So $80, or sorry, 80 kilometers is $100. 80 kilometers is $100. So I'm going to find my slope for both of those two graphs. So I've got the M here and I've got M here. So I go Y2. So 100 minus 40 over 80 minus 0. And over here I have 100 minus 60 over 80 minus 0. Okay? So the rate at which the wheels to go goes up is 60 over 80. All right? So I can then say that it is 75 cents a kilometer. All right, I reduce this 60 over 80 to 3/4. But remember, I'm talking about the amount of money over the amount of kilometers. So that's 0.75 cents. So 75 cents a kilometer. This guy, on the other hand, is 40 over 80, which works out to 50 cents per kilometer. I'm just going to make this a little bit smaller for a second. So what does that mean? Okay, so the wheels to go, to calculate its cost, it's 0.75D plus 40. And the direct, called direct cab, isn't it? Car, direct car, all right? Its cost is 50 cents per kilometer, but you start at a rate of $60. All right, so let's look at A. We already explained that by looking at it. It says Jenny thinks she'll drive about 100 kilometers. Which company should she choose? If she's going to drive over 80 kilometers, the direct car is the better one. Under what circumstances should Jenny choose direct car? Well, she should choose the direct car if she's going to drive more than 80 kilometers. And how does the point of intersection of the lines relate to the decision about which company to choose? Okay, so looking at that graph then, what does that tell us? It says that if I'm going to drive under 80 kilometers, wheels to go is a better deal. If I'm going to drive over 80 kilometers, direct car is the best way to go for that rental car situation. All right. So I went through that fairly quickly. Does that help, Emma?
Yep. Thank you.
Okay, no problem. All right, were there any other questions out of that chapter 8 that you wanted to see, girls? Or Pedro? Anything out of question 8 there, or out of chapter 8?
Nope.
Nope. Pedro, you okay?
Yeah, I'm okay.
Okay. Hey, Pedro, I got a question for you. Did you send me your last assignment?
No, not yet.
Okay, I just needed to make sure because I have some without names on them. So if you send that to me that anytime this week, that'd be ideal, okay?
Okay.
Okay. All right, so we can move on to chapter 9 then. I want to go through this one fairly slowly. I'm actually doing chapter 9. This is an important one for grade 11. So, and I'm actually doing this with the grade 11 pre-calc today as we speak. So, when we're solving systems of equations, so that's what you were doing. We're trying to find intersection points of graphs. There are 3 methods that we can use. The first method is to graph them. So we graph them and we find out where they intersect, or if they're parallel lines and there's no intersection, or if they're the same line. The second way to do this algebraically is what we call the substitution method. All right, substitution. Struggling this morning. And then the third way is the elimination, but we'll worry about that a little bit better, or a little bit later. Okay. So, the substitution method. We have 2 equations given to us. The first equation is this. So the first thing I do is I identify my 2 equations. So 5x plus y equals 11. There's equation number 1. Equation number 2, or B, whatever, is 2x plus 3y equals 7. Okay, now, what you're going to determine as we go through all of these questions is which of the 3 methods best allows us to solve these questions with the least amount of work. Okay, and sometimes there's dead giveaways. All right, in the elimination method, the values are the same in A and B, so it'd be a 2x and a 2x. That would be one way to do it. Okay, in the substitution method that we're going to do, we want to find the one variable that has a coefficient of 1 in front of it. And then what we're going to do is we're going to solve for that one variable, and then we're going to substitute it into equation B. Okay, so this is what it looks like. In A, I see that there's a 1 in front of the y. So I'm going to work with it. 5x plus y equals 11. Now what I'm going to do is I'm going to solve for the y value. I'm going to solve for the y value. So y is equal to minus 5x at 11. So basically what I did is I turned it into y equals mx plus b. But if the coefficient of 1 was in front of the x, I would solve for the x and substitute there. So now what I'm going to do is I'm going to use equation B now to solve. And instead of putting a y in here, all right, instead of putting that y in there, I'm going to substitute in minus 5x plus 11. That goes right here. Instead of the y, and that equals to 7. So what I'm doing is I'm substituting in from A for the y here. Now, what does that help us do? Well, what that does is that allows us to now only work with x. So I can find the x value of the coordinate where they're going to intersect by using this information right here. Transfer through the brackets. (2x minus 15x plus 33 equals 7. So what I've done here is I've multiplied 3 through the brackets. 3 times negative 5x is negative 15x. 3 times 11 is 33. I'm going to collect my like terms. 2x subtract 15x is minus 13x. I'm going to subtract 33 to that side. I get minus 26. All right. Now I solve for x. I divide by negative 13. X is equal to 2. So I have now found the x value of the vertex, or sorry, of the intersection point. So I found the x value of the intersection point. I need to find the value of it in order to finish the question. So at this point, I can use either equation A or B. It doesn't matter which. And I'm going to put x in, 2 in for x, and then solve. So I'm going to use A, 5. So instead of x, I'm going to put a 2 in there. Plus y equals 11. That gives me 10, add y equals 11. Y is equal to 1. My coordinate is 2. I'm just going to move this because I want to do something different here. My coordinate is then my solution, which is 2 and 1. So using the elimination method, I get rid of one of the two variables. I worked with x. Once I solve for the x, I substitute it in for x in one of the two equations, and then I solve for y to get my answer. Now I can check my answer to make sure I got it right. The first way you can check it is using Desmos and graphing it. So that works great. That's slick and easy. The second way would be to put it back into the second equation and make sure that the left side equals the right side. So I go 2 times 2 plus 3 times 1, and it should equal 7. 2 times 2 is 4. 3 times 1 is 3. 3 and 4 make 7. I know I've got the correct answer for it. This is what we call the elimination, or sorry, the substitution method. Okay? Now, what we're going to find out is that when we use the elimination method, the only thing that is different is this part right here. Okay? How we solve this is different. This is the same in all three methods, especially the elimination and substitution. Okay? So we'll try another one here. Now they get it. They start you with a hard one where you got to write out. Look at page 192. It says Ryan bought 3 tickets and 6 hot dogs at an Edmonton Rush lacrosse game. The total cost of his purchases was $153. His friend Carrie bought 1 ticket and 3 hot dogs and spent $54. What was the price of a single ticket? What was the price of a hot dog? Okay. So the first thing I should do in all of these questions is write out what we call this in grade 11 applied, we call it the defining statement. So the defining statement tells us what does X represent, what does Y represent. So X represents the ticket price, and y is going to represent the hot dog price. Ryan bought 3 tickets and 6 hot dogs. So equation A, 3x plus 6y equals 153. In B, Carrie bought 1 ticket and 3 hot dogs. And that equals $54. Okay, so you now have 2 equations. And again, I am looking for, in either one of the 2 equations, the one variable that has a coefficient of 1 in front of it. Okay, and looking at the 2 equations, I recognize that in B, there's a 1 in front of the x. So that's the one I want to solve for. That's the one I want to end up substituting in. So here's how this works. I'm going to use B. I'm going to subtract 3y from both sides. So I get x equals minus 3y plus 54. So what I've done is I've isolated. So that's the first step that you want to do. After my defining statement, I write out my equations. I want to isolate. All right. So if you, let's say, and that's it for today, is get through 1 to 5. That would be a good start on this section. Any questions? Okay. So I'll leave you on again. I'm just going to shut my mic off. I'd like you to work, I don't know, for another 15 or 20 minutes. Go through question 1 and 2, and then and see if you can do it. And if you have any questions, I'll stay here and wait for you to ask. All right.